and that's so that I can have a kind of proof of attendance. Okay, good. So now we're getting going, and we're recording, which is great. So again, we're going to cover the rest of chapter 1 today, and just start a little bit into chapter 2, and then also next week you have your first Connect Maths due, the homeworks due. So you'll have chapter 1 homework due on Tuesday, and chapter 2.1/2.2 due on Thursday. And what you're turning in to me in terms of assignments, those are not homework. That's just proof of attendance. So I'm just kind of a heads up on the difference in that one. And again, we're not going to learn how to play poker in this class. Instead, bring Harrington on Hold'em. It's an excellent poker book. Highly recommended. So that is a great thing to meet all of your poker learning needs. All right, great. One other thing is, if you have taken Math 40 before at Las Positas and you've purchased the Connect Math program, you do not have to purchase it again. If they prompt you to purchase it again, or say that you're about to, your code is about to expire, email me your name, your username, and your email address for the use to set the account, and I will get it extended. I'll get you an extension. So don't buy it again. Whether it's here, if anywhere at Las Positas, if you purchase the Connect Math for Bloomin', you do not have to do it again. All right, so this is sort of where we left off last class. So maybe if I can get somebody to read this, how about Ulysses? Go ahead, you're up. Sure, why not? Yes, both of them.
A statistic is a characteristic or measure obtained by using the data values from a sample.
Yep. Keep going.
A parameter is a characteristic or measure obtained by using all the data values for a specific population.
Good, thank you. So you'll notice the key thing, the key level, it's kind of nice, letter, in this sample starts with the S, right? So it means that anything you compute from the sample, like, for example, the average, standard deviation, how large the sample size is, those are all statistics. And you'll see that S, sample, S, statistic, that works out really nicely. So, don't think that a statistic is something fancy or weird. It's just something calculated based off of a sample. For a parameter, it's the same idea. It sounds fancy. It's just something that was calculated based upon a population. So in other words, the population average, the population standard deviation, the number of people in the population, all those sorts of things, those are parameters. These are things I want you guys to think about in terms of statistics when you're hopping in here. So how about Brenda? Go ahead and read for us this page.
Okay. Things to think about. What does the data mean? What is the goal of the study? Be skeptical of the source. Is the source objective? Is the source biased? Be vigilant and skeptical of studies from sources that may be biased. Exactly.
And very often people are biased, right? People who do the studies tend to be people who have, reason to want something to happen. They're doing the study for a reason, so they typically want a certain outcome. So you should be super skeptical of, just in general of biased sources. And, that's the majority of sources, actually. All right. How about Alay? Go ahead and read this one for us.
Descriptive statistics consist of the collection, organization, analysis, and presentation of data, for example. The differential statistics consist of generalizing, for example, the population, determining relationships among variables, and making estimations or predictions, the probability or hypothesis.
Exactly. Thank you. So yes, descriptive statistics are based upon samples, and that's information we have, and those are facts. So descriptive statistics are whenever you have everything and you're stating facts. Like, I know that the average income of these 10 students or these 10 people is blank because I know all 10 of them. I know that the average height in my statistics class, in our class that we have now, is blank because I can measure all of you and have all the information and know what your average is. So those are basically facts, things that you've collected. You have the numbers. You begin competition upon it. Inferential is when you take those facts that you know based upon your sample, and you're making guesses. Often population, it doesn't have to be population, but you're making a guess or a generalization. You're making an estimation, a prediction. Those are not facts. You are guessing at that. So inferential statistics, those are not factual. Those are best guesses, if that makes any sense. It's an inference. An inference is a guess. Whereas a descriptive descriptive is, that's a fact. Those are actually, the averages or the standard deviations or the whatever it is. So these, I believe, are in your notes. We're working on Chapter 1 notes if everyone is not aware of that. What do your Chapter 1 notes look like? They look like this. All right, so we're filling in this stuff here. We're filling in specifically these two right there. So you should have your chapter notes out and should be working on this. Filling these in. Okay, great. Next, I want you guys to go to your Jamboards. Oh no, I'm not ready for that. Okay, hold on. All right, go to your Jamboards, but just ignore the first two boxes, which are messed up. So I'm going to put you guys into new breakout rooms. What I want you guys to do is introduce yourselves. So you have brand new people. Remember, every day for the first 3 weeks, I'm going to have you guys into a brand new breakout group so you can learn people and get to know people and figure out who you really want to work with. So let me get that Jamboard. Here's our Jamboard. Oops, this is the afternoon one. That's not you. Here's you. So I'm going to cut and paste this into your notes. Everybody go there. Go to that document that I just sent you in the notes. That's this one here. It'll tell you what link to click on to get to your breakout room. If you're doing it via phone, you can do it that way too by going to our class here and going to our home page. And if you scroll down the home page, you'll see here under Jamboards the same exact link. This link is the exact same link that I just texted you guys. So you can click on that. It'll take you to the same spot. And that will tell you which Jamboard to go to based upon your breakout room. Again, remember, you're not in the same breakout room you were last class. It's a brand new one. So when you go to your breakout room, pay attention to the number. It's a different number than it was last time. So I'm going to go ahead and recreate these. All right, so go ahead and hop in there. Dylan, actually, I'm moving you to, Guru, I'm moving you to a different room. So don't hop in there yet. Oh, you can hop in there, that's fine, but I'm going to move you to 4.
So I click on number 4?
Yeah. Guru, you're in 4.
Professor Young?
Yeah.
I'm still in breakout 6.
Who are you?
Brenda, sorry.
Nope, Brenda, you're in a different room now.
Okay.
Yeah, Brenda, you're in 8. You're welcome.
Our room stat.
The link I sent you. Yes. You don't know what room you're in. Is that so? Who said that? Mary?
Mary, like anything also.
Ask the people in your room what room you're in.
No.
Oh, I'm sorry. Okay. Well, that certainly helps. So it's there. I didn't see it. Jamboard 2. Oh well. I don't know. You're not in group 2. I don't think. No. So yeah, so group 2 is Dylan, Gavin, Kristen, Olivia. You guys got to write stuff in your Jamboards. All right. So let's go ahead and go back to here. So first off, the average jackpot for the top 5 lottery winners was 367.6 million. Is that a fact or is that a guess? It's a fact. Right, so is that descriptive or inferential? Descriptive. Descriptors are facts. Great. How about the next one? Studies suggest that older people who had a high caloric diet more than double the risk. Is that a fact or is that a guess? It's a guess. So that would be inferential. That's a guess. And then the next one, based upon a survey. So the first one is based upon a survey of 9,317 consumers. The average amount that these consumers, those 9,317 spent on Valentine's Day in 2011 was $116. Is that a fact or a guess?
Fact.
That's a fact. That's a fact about these 9,317 consumers. These guys here, their average spend was 116. So that's a fact. That's descriptive. So the question comes up then, what about if I said, well, based upon the survey of 9,000, the average that all consumers in the U.S. spent was 116. Is that a fact or a guess? If I base upon the survey of 9,000 people. That's a guess. I'm making a guess about everybody in the United States and not just those 9,000. So that would be inferential. And the last one, scientists at Oxford found a good laugh significantly raises a person's pain tolerance level. Did they ask you? I didn't get asked. Did they ask you guys?
No.
Right, so they didn't ask everybody. So is this a guess or is that a fact? Guess. So what is it? Yes, it's an inference. It's a generalization about everybody based upon your survey. Good? All right. So sure people are on board with that part. And remove it now. I'm okay for next class. All right. Let's get a reader for this one. How about Jamila? Go ahead.
Qualitative variables are variables that have distinct categories according to distinct characteristics or attributes, i.e. gender, zip code, hair,
keep going.
Quantitative variables are variables that can be counted or measured, aka numerical, discrete and continuous. Discrete have values that are countable, number of pets, money. Continuous has infinite possibility of values between any two specific values. Real numbers from 0 to 1, temperature, and are usually obtained by measurement.
Perfect. Thank you. Excellent. So you'll notice between qualitative and quantitative, one of the differences is that qualitative has an L in it, and quantitative has an N in it. I like to grab that L and use that for label. These are all labels. Zip code, yes, zip code is technically a number. 94566 is my zip code, but does that really have a numerical value to it? Is 94566 higher ranked or worth more or than zip code 01437? No, it's just a label. It's a label. Same with like football player numbers, right? Is player with a number 84 better or higher ranked or worth more than player number 6 who has a number 16 on his back? No, right? Those are just labels. Quantitative, that N, that's new. You can use that to remind yourself it's numerical data. Quantitative are numerical data. There's two types. It could be the discrete, which are they have values that are countable. For example, number of pets or money. Money is countable because it has a it can be a decimal, right? I can have $1.04, and I can count that. It's so it can be decimals as long as it's a fixed number of decimals. And then continuous is the other thing. So quantitative can be either discrete or continuous. Continuous, those are things that you measure. So we're going to talk about that in just another second. So here again is sort of it's in flowchart form. So your data can be either qualitative, categorical, or quantitative, numerical, which means you can rank them. They're ranked. If it's discrete, then there is a finite number of data values between any two numbers that are in there, any two possibilities. For example, between 0 and 1, if I'm talking about money, money is discrete. Between $0 and $1, I can have 0.01. I can have 1 cent. I can have 2 cents, 3 cents, 4 cents, 5 cents, all the way up to 99 cents. Those are countable. There's a lot of numbers between 0 and 1, but I can count them, right? 1, 2, 3, 4, 5, all the way up to 99 cents. Continuous, however, between 0 inches and 1 inch, if I'm measuring, I could have 0.1 inches, which is different than 0.11 inches. Right? Imagine zeros behind all of these, which is different than 0.111 inches, which is different than 0.1111 inches. So I can just keep going on and on like that forever because it doesn't have a fixed number of decimal places, and I would never even get to 1.2 inches. Right? There's an infinite number of data possibilities that you can find. The easiest way to remember it is discrete are things that you count. Continuous are things that you measure. Everybody absorb that. We're going to be doing a little bit on that right now. So discrete, things you count. Continuous are things you measure. Questions about this before we move on? All right. So private chat your answers to me. So in the private chat, I want to hear from everybody. These are these discrete or continuous? So the very first one, high speed of a hurricane, is that discrete or continuous? Everyone chat. Private chat. 3 people so far. 4 people, 5, 6, 7, 8. If you don't know, put I don't know or put a question mark. About 20 people. private chat. Private chat to me. So what you hear from some people, this all goes into my, saved into my stuff for later too. This is part of your participation grade. All right, so high speed of a hurricane. Do we measure speed or do we count speed? Measure. So is this going to be measure, things to measure, or continuous? How about weighted baggage on an airplane? Do we measure weight? Do we count weight or do we measure weight? Measure. So that's also going to be continuous.
Wait, were we supposed to do all of them or just one?
No, you're right, I'm going to pause. I'll pause in between. Just one. I want to kind of get you guys all on board and woken up. Now, some of you may have decided that weight of a baggage on an airplane, like when you come in and you put your baggage on the thing when you check in, that it measures it and it gives you a fixed number because you only have like the nearest tenth or the nearest hundredth of a pound or something like that. That's what we call discretizing. In other words, you're taking something continuous and you're making it discrete by rounding it to a certain number of decimal places. So if you explained that in an exam and said, well, it's discrete because really you're measuring it, you're rounding it off to the nearest hundredth or something like that, then that would be okay. But otherwise, unless you've given me that explanation, weight itself is measured, so it's continuous. So what do you guys think about number of pages in the textbook? Everyone chat quickly. Number of pages in the textbook. Sorry, my bad. Do you count the number of pages or do you measure the number of pages? That's the big question. You count. So this would be discrete. Perfect. And the last one you guys think about, the amount of money a person spends each year on online purchases. So chat to me whether it's discrete or continuous. 9 people, 10, 11, 12. Do you count money or do you measure money? That's the question. Check. What does it mean? Email a check? All right, so you count money, so this is discrete. Makes sense? So how much money you spent last year? That's only a fixed number of possibilities in there. Okay, great.
It's just like the wording for the second part of the question, when that was about the weight of the baggage, like on the airplane, it's just like grammatically, it just kind of sounds discreet.
Yeah, but the thing about it is, you have baggage on an airplane, and it could be any amount, right? If a little bit of dust falls on top of my bag and sits on my bag, then all of a sudden it's a micro amount more than it was before. So that's the thing about it. It has an infinite number of possibilities in there in terms of weight. Well, so discrete can be whole numbers, but it can also be decimals if it's a certain number of decimal places, like a specific, like money is 2 decimal places, right? Our money is like $14.13, 2 decimal places. I'm never going to have 14.137, dollars in my pocket. It depends upon, and, if the decimal places are fixed, basically, then that would make it discrete. But if there's an infinite number of possible decimal places, then there's an infinite number of possible numbers. So yeah, that's another way of looking at it. Good question. Anyone else have a question or a comment? Hop on in and say something if you want. Yeah.
Professor, yes, in text, will we have to explain things?
Yes.
However we,
If I say and why, if I say and why, then yes, you do. If I don't say and why, then you don't. So this one is a good one to get in the practice of saying and why, because a lot of times you guys will interpret it differently. So like if you said the way baggage on an airplane, because it's always to the nearest tenth, so it's discrete. Then you get full credit, right? But if you're thinking that and you say discrete, then you're not going to get credit for it. However, you said, oh, weight is measured, so it's continuous, then again you get full credit. Does that kind of make sense?
yeah. Okay.
So this one is a good one to explain just because it can go either way depending upon your explanation. All right, so here's us talking about taking data that is continuous and making it discrete, discretizing it. So for example, I have a ruler. It only goes in whole centimeters. It doesn't have half or a quarter centimeters or tenths of centimeters. It only goes in whole centimeters, which means that if I have this, let me get back to me. If I have this this ruler and it only goes in whole centimeters, then I can't measure 15.6 centimeters. So here's my 15, here's 14 centimeters, here's 16 centimeters. Everything that's 14 and a half to 15 and a half, I'm just going to call that 15. Does that make sense for folks? So the boundary for 15 is anywhere from 14 and a half to 15 and a half, that's going to be 15. And those are the boundaries. Let me go back to my screen share. For temperature, so here's kind of the easy way of doing it. Easy. It's not really easy because I can't write with this thing. Annotate. Okay, so the easiest way to do it is to say, here is my number. What's the number before me? 14. What's the number after me? 16. And then find the number in between. So smack that between 14 and 15 is 14.5. And smack dab between 15 and 16 is 15.5 centimeters. All right, so how about 86? What's the number in front of 86? Not hard. 85, great. Number after 86? 87. So then we take these two, find the number, the boundary between them, right? This is your yard, this is my yard. The fence between us is at 85.5. Degrees Fahrenheit. And then between these two guys, the boundary between them, smack dab by the middle, is 86.5 degrees Fahrenheit. I'm going to leave it off because it's just too confusing. It doesn't look, well, now that I've done this, I got to kind of go with it, I guess, all the way. All right. Now it gets a little bit trickier. This is my hint, and for any of you guys who do not like decimals, think of it as a whole number. So think of this as 43. What's the number in front of 43?
42.
42? What's the number after 43?
44.
44, perfect. Now, look at your original number. Where should the decimal place be? Before the 4. You guys understand that? So just pop it in wherever it belongs. You can tell from the first one where you can kind of see where it should go. Then, great, what's the number halfway between these two? you could put them in your calculator and average them, or you can say, well, what's the number halfway between 42 and 43? It would be 42.5, so I'd put 425, and the decimal place stays where it is. Another shortcut is, let me tell you guys, this is important. Boundaries have one more decimal place than the original data was in. So it should go one more decimal place. So I have 0.42, take the lower one, just add a 5 to the end of it. Done. Between 0.43 and 0.44, take the smaller one, 0.43, and just add a 5 on the end. Done. Just like that. The only thing you have to remember with the whole numbers is you have to add the point, right? It's the point. But you guys, I think you don't have as much trouble with the whole numbers anyways. All right, this one down below, you guys can do your own in a minute. I'm just doing some examples with you guys. So again, make this into a whole number, 16. Remember, in front of 16 would be 15. The number after 16 is 17. And then put in your decimal place. Okay, it goes after the 1. So right in there. And then between 1.5 and 1.6, just do 1.5 and add a 5 to the end. Piece of cake. Done. Let's have my touch screen at least. And then here, between these two, 1.6, and just add a 5 on the end. Because remember, the boundaries are always one more decimal place. Just going to add a 5 to the end of the lower number. Okay, so now that I haven't totally screwed up, these are in your written notes. Okay, so in your written notes, write these in your written notes. I'll give you guys a couple minutes to do that, and then, after a minute or two, discuss it with your neighbors, get them down on your Jamboards as well, and then come back. So, and make sure that if you weren't sure, that you clarify that with your Jamboards and with your neighbors, and then fix them on your written notes. Okay, so I'm going to go open up the rooms, hop in there, get on your Jamboards. It's the next page, so just go to the next page on your Jamboards, and you'll find it.